Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. Today I will discuss the reaction of anions that in question 3 of the paper 3 AS level chemistry. You know that before doing the before discussing the test and these notes of the anions, you should know the solubility of the salts, because salt, we know that salt consists of aqueous salts consist of two types of ions, cations and anions. Cations are, you in other words you can say, the basic, and anions comes from the acid, and these are the acid radicals. And you know that common anions are sulfate, carbonate, sulfite as well, uh, nitrate, chloride, bromide, iodide. The solubility of these salts always in your mind, that you know that soluble, insoluble. So all sulfites are soluble except all except calcium, barium and lead. Similarly, all sulfates are soluble except calcium, barium and lead. All carbonates are insoluble except ammonium carbonate and group 1 metal carbonate. All nitrates are soluble. All chlorides are soluble except silver, lead. All bromide are soluble except silver, lead and mercury. And all iodides are soluble except silver, lead and mercury. So you should know the solubility of these ions, and you know that when, if chlorides are present, you should know the test if the written as that add silver nitrate plus acid HNO3, few drops. It must be for halide ions, and if halide ions are present, you know that chloride ions gives white PPTs with this test. These are the halide ion test. White PPTs, bromide ion has off-white PPTs and iodide ions will give yellow precipitate. To further confirm these tests, add ammonia, solution. White PPTs dissolves. Add ammonia, aqueous white PPTs partially dissolve. Partially dissolves. And if we add aqueous ammonia, yellow pipette is insoluble. So if halide ions are present in the given solution and this test is given, add silver nitrates. So it must contain chloride or bromide or iodide. So you can identify by doing these tests further. So white precipitate of chloride ion, off white bromide ion, yellow precipitate of iodine. And off white, there is very little difference, small difference between white and off white. And if you can't identify white and off-white peptides with whether chloride and bromide, confirm it by addition of aqueous ammonia. If aqueous ammonia, white peptides dissolves in case of chloride ion, but white peptides partially dissolves in case of bromide ion, and yellow precipitate insoluble in aqueous ammonia. So this is further confirmation of halide ions. So if solution contains sulfate and sulfite ions, sulfur containing, if the ions contain sulfur containing species, sulfur contains, we have two ions, SO4, sulfate and sulfite ion. So at, if written in the test is add barium nitrate or barium chloride. It must be for sulfate and sulfite ion test. So if we add barium chloride, white PPTs are formed. So how to differentiate between sulfate and sulfite ions? Add dilute acids except sulfuric acid. You can add dilute hydrochloric acid or dilute nitric acid. Then if white PPT is insoluble, the solution contain sulfate ion, and if white PPT dissolves, white PPT dissolves and it gives gas which turns acidified potassium manganate solution from purple to colorless. Then it contains sulfite ions. So in this way you can identify that whether sulfate or sulfite ions are present. So there are two species which contain nitrogen atoms. So nitrogen containing species. The nitrate ion and nitrite ion. Add sodium hydroxide plus aluminium foil. Both gives ammonia gas, which turns red litmus, which turns damp red litmus paper blue. So to differentiate these two anions, add dilute acids except nitric acid. So the observation would be, if brown colored gas is evolved plus strong heating is evolved, it conforms nitrite ion. So now carbonate ions. For carbonate ions, add dilute acids, effervescence, which turns lime water milky. Sometimes FAs contain sometimes solid samples are given in question number 3. If solid samples are given, then solid samples contain ammonium salts, nitrate salt, nitrite, or carbonate. If solid salts are crystalline, then nitrite, nitrate, and ammonium salts are present. Exist in crystalline solid. And if powder, then that must be carbonate. If white crystalline solids are heated, heat the solid and white fumes are produced. If white fumes are produced, it must contain ammonium ion. To further confirm this test, dissolve this solid in water and add sodium hydroxide plus warm the solution. So it further confirms the ammonium ion. The observation is ammonia gas is evolved which turns damp red litmus paper blue. This test will further confirm the ammonium ion. So solid samples, ammonium ions, nitrate and nitrite ions are white crystalline solid and carbonate in the form of powder. And if the white crystalline solid is there, then heat the solid, white fumes are produced which confirms ammonium ion. To further confirm this ion, dissolve this solid in water, add sodium hydroxide plus warm it. So observation would be ammonia gas is evolved which turns damp red litmus paper. This test will further confirm the ammonium ion in the given sample. If white crystalline solid melts on heating to form liquid, then it means nitrate and nitrite ions are present. So dissolve this solid in water and plus sodium hydroxide plus aluminum foil and warm the solution. If ammonia gas is produced, then both nitrate and nitrite ions are confirmed. To differentiate between these two ions, add dilute acid except nitric acid. If brown colored gas is evolved, then nitrogen dioxide, brown colored gas nitrogen dioxide is produced, then it confirms nitrite ion. But if no gas is there, it confirms nitrate ion. Hope you will like this, you will understand this and how to learn these tests before doing the question.